Hello.
So you guys can see my screen, right? Just, yeah. Also, like, if you guys have any questions, just like unmute yourselves because I can't see you guys from my screen. All right. So today we're gonna go through some like basic algebra. It might be like really easy for some of you guys because it's just gonna be basic factorizing and like expanding and stuff. Yeah. Yeah, okay. Um, so first let me introduce myself. I'm Sophie and I year 10. Yeah. Okay. So we're gonna go through what is Olympiad algebra, and then we're gonna go through some basic factorizing as well as a little bit of expanding, and then go through some well-known identities. And then like you guys had the handout I made, right? I think they should have emailed it to you, and then if we have time at the end, we can go through some problems on the handout. Yeah. Okay, so what is Olympiad algebra? Well, it's like special type of algebra that's like used in math competitions, and then you basically have to like use algebra skills like, and then you just like apply them creatively to solve problems. Yeah, and then it's like usually more advanced in school algebra, and then you have to like use like smart methods to like try and find ways to solve the problems. And like the main topics are like polynomials, equations, inequalities, and also like functions. Yeah. Does that sound good? Okay, so today we're gonna talk about factoring, identities, and algebraic manipulation. So first of all, like basic factorizing. All right. Yeah. All right. And then so factorizing is basically like the reverse of expanding brackets. As you can see like in this diagram here, it's basically just taking out like I guess like common factors, and then you just like basically you just plug that into that. You have like this expression, and then you can turn it into like brackets. Isabel, can you stop texting me? Thank you very much. Yeah. So like expand, let's first talk about expanding brackets because you basically have to like know what expanding brackets are before I guess factorizing stuff, right? Expanding brackets. So first of all, if you have like something like 5 times oop x plus 3, then how do you expand that? Yeah, Kingsley, you can unmute yourself.
You do 5 times x, then 5 times 3.
Yeah, you can you multiply, what the hell? You multiply these two and then you multiply these two, right? And then you get 5x plus 15, all right? All right. So what if it was two brackets like this? Sorry, I'm on laptop right now, so it's kind of goofy. X plus 6 times x plus 8. How would you do that? You guys can just unmute yourself and shout like how you would do this. Oh, wait, you're drawing on my screen. Sure. Right. Yeah. Yeah. So so you need yeah, can you explain how you got 14x?
Never mind. Odd. I did 6 times x and then x times 8 and then plus them together.
Yeah. So like basically, oh, can you like erase your stuff off? Sorry. Yeah, that's correct. Like when you're expanding stuff, you need to make sure that every term in each bracket is like multiplied with every term in like the other brackets. Like for example, in these ones, these two have to get multiplied together, and then these two, and then these two, right? So the full written out one is x squared because that's x times x plus 6x because it's these two, 6x, and then plus 8x because it's the first and fourth term, and then plus 48, which is 6 times 8, right? What if it was three brackets? Let's just say x minus 2, and then x plus 3. Oh my god. Sorry for my really bad handwriting. Times x plus 4. How would you do this? I'll give you 30 seconds to think about it, and then someone can just unmute themselves and just shout out the answer. X cubed plus. Yeah, I think that looks about right. Yeah. Does anyone want to have a go at like explaining how they did this, like step by step? Okay, you can just unmute yourself. Do you want to unmute yourself?
Multiplied all the three. Multiplied like if I went like that, then I went like that, and then I got that answer, and then I multiplied
Um,
or something. I
but
multiplied.
I wasn't talking to you, but it's fine. Because like you already done one, so like maybe let someone else have a go. Who's lol? Can you like change it so it's your real name? Sorry. Do you want to have a go at doing this?
So basically there's the x's, and since they're like the same, you can put them like together kind of. And there's x, 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 so then you can times them all together, which makes 3, no, x to the power of 3. And then you have like, so you times these 3 together, and then you could do like, oh yeah, I'm stuck, whatever.
I get what you mean. Wait, this is actually really hard to use. Maybe I can just use Zoom whiteboard, but it's okay. Anyways, yeah, so you have to make sure that every single one of these gets like matched with every single one of these, right? So like the first x, you have to make sure it gets matched with x, and then that just makes the x cube term, and then you can go x and 4, and then that's 4x squared, and then you basically just times all like the possibilities, right? But then Kingsley's way was also really smart. Like what he did was, wait, can you please rub out these stuff? Sorry. So like, yeah.
Sorry.
Thank you. So like what he did was expanded these two brackets first, and then use that to, and then that multiplied by this one. So I think he got x squared plus x minus 6, and then that, because this bracket is basically just this bit expanded, and then times x plus 4, and then you just expand it again from here, and then you just go x squared with x, x squared with 4, x with x, x with 4, and then 6 with x, and then negative 6 with x, and negative 6 with 4, and then you basically can just get the fully written out version is x cubed, oh my god, plus 4x squared plus x squared plus 4x minus 6x minus 24. And then you can just collect like terms, these two, and then what? Oh wait, no, it's fine. These two, and then these two, and then you just get the answer. Is that all goods? Reasonably happy? Yeah. Okay. Wait, can I just change to using the Zoom whiteboard, because it's really hard to yeah, sorry. Stop sharing. Yeah. There. Okay. All right. So moving on to factorizing, it's, well, you guys kind of have like, you guys kind of know what expanding is now, and then we can and factorizing is basically like the opposite of it. All right. For example, let's get like an example. So, what the hell? Anyways, let's say 3x plus 6. How would you like factorize this, assuming it's like the opposite of expanding. Yeah, that's right. It's 3 times x plus 2, right? Because you're taking like a factor of 3 out of the 3x term, and then you're also taking like a factor of 3 out of the 6. So you basically just put the 3 at the front and turn it into 3, and then like you divide this term, the 3x term, by 3 and divide 6 by 3, and then you just get the x plus 2 term. Is that all good? Okay. Let's move on to, let's just say, oh, why does it not work? Why does this not work? Okay. What if it's like there? What about this one? Someone could just like write it down here. Yeah, that's right. It's because you're taking a 2x term, you're taking a factor of 2x out of here. So well, I guess you can just write this term as 2x times x now. And then you can write this one, the 8x, as 2x times 4. And then you basically just take the 2x out from both sides, and then you get 2x times x plus 4. Is that all good? Yeah. Okay. Okay. Let's move on to factorizing quadratics. So some of you guys have like touched on quadratics before, right? And then you guys kind of know how to do quadratics, right? So I'm gonna give you some problems. Because I had like a whole list before, but I don't know why it's not working, so I have to screenshot it. And sorry. Would someone like to like verbally explain how they would do this? Like any tricks they use to get the answer from this? Okay, would you like to unmute yourself? Can I do that? Am I allowed to unmute people? You guys can just unmute yourselves and shout out the answer.
Wait, so basically, do you just like factorize it first into the thing we were doing before?
What do you mean factorize it into the thing we were doing before?
Like factorize it so it like is like
Yes, you factorize it so it's yeah. So you factorize it so that it can't be factorized like even more. Like take x plus 2 for example. You can't. There's no more common factors. Like you can't factorize it anymore. So like that's when you just stop factorizing.
Also, what is this thing equal to? Like x squared minus 3x minus 10?
This thing, oh yeah, equal to 0.
Okay, so then this thing is also equal to 0. And basically, each of these like this has to be equal to 0 and this has to be equal to 0 because two things and then
Well, like, I'm not asking you to solve for x. I'm just asking you to factorize. Sorry. Yeah, but if you were to solve for x, that is going to be like what you're gonna do. That's a good point. Kingsley, would you like to like touch on how you got the two brackets? Because I know like some people just guess and check.
So one my math teacher told me, so like what is this thing?
Proof
Yeah.
by teacher.
So like there's this, so you have x and x, and then you have, for example, -5, and then you have 2, and then it's like that, and then x times, I kind of forgot about, but it's kind of like that,
Yeah.
and then it's 2x and -5x, and you add them together, and if it equals the middle number here, like -3x, then you can use it going this way. So it's x minus 5 and x plus 2.
Yeah, because we know that like the middle term is made out of these two and these two added together, right? And then the constant term, which is like the 10 in this case, is made out of this times this, right? So, yeah. Um, yeah. I guess lol. Wait, what's your name? Sorry. Would you like to unmute yourself and like tell us like how you would do it?
me
Yeah.
um so basically from the brackets form you like times these two together to make like this number at the end, so then we can use that like basically a pair of factors that make 10 that like add and or subtract to make this thing to make 3.
What do you mean add or subtract? Like for example, I could have like 5 minus -2. That's 7, right?
Yeah, but then you can also just have 5 minus 2
Yeah. So like you need to be like rigorous. Like why does it have to be 5 minus 2?
because that makes 3 and it has to make this number here.
Um, well, I get what you're saying, but then the thing is like it's basically like we can just regard -2 as like one thing, right? So we can just go -2 times x plus 5 minus x. So it is like the two plus together because it's like -2 is just like one thing, right? So and that makes wait, hold up. This is -3. Yeah, sorry, it's -3. It's not +3. So that's actually wrong. Because we realize that um this expanded would actually make x squared plus 3x minus 10. So can you fix it?
Right.
Because the question asks for minus 3x.
Yeah, I have no clue.
So basically, we can just change this plus into a minus and then this into a plus, and then that's going to make -3, right? Because -5 plus 2 is just -3, right? There is like a trick to doing this, I think, but it's basically just like the same as what we've been talking about. Let's take the first example as our thingy. So we basically define like we have like a add number, and then our add number is just going to be the middle term. And then we have like a multiply number, and that's going to be the first term times the third term. And this, in this case, it's just going to be 1 times 6, which is just 6. But sometimes like the first number isn't 1, right? And then since it's just 1, so we don't really need to do anything. So we need to find two numbers that add up to 5 and multiply to 6. All right, and in this case, we realize that 2 and 3 fit these like conditions. So we can just put 2 and 3 into the brackets and turn it into x plus 2 times x plus 3. Does that make sense? Can you give me like a thumbs up if it makes sense? All right. Okay. But sometimes the leading coefficient, like the first coefficient isn't 1. So let's do like a problem where the coefficient isn't 1. All right, let me just screenshot and paste it in. Try this problem. Wait, who wrote this? Who wrote this? Okay. Um, would you like to explain how you got this?
So we started with 2x squared plus 7x plus 3, because sometimes I like to break into 2x times x
Yep, 2x squared.
plus 7x plus 3. So, and then I like to put it using the method before, like 2x and then x, and then the factors of 3 are only 3 and 1, so it has to be some order
Yeah.
of 3 and 1. So we put 1 here and 3 here, and then multiply. So we get 2x times 3, which is 6x plus x.
Yeah.
So then after that, them plus together is 7x, which is our middle term.
Yeah.
So 2x plus 1 and x plus 3.
3x plus 1. Oh, 2x plus 1. Yeah, that's right. And then we can use our little trick from before, and then but this time it's the plus is still 7, and then the multiplying terms, it's the first term times the third term, so that's 6. We need to find two numbers that add up to 7 and multiply to 6, and then we know that it's 1. Oh, did you just delete the question?
My bad.
1 and 6, right? But we know that the leading, like this coefficient, it's 2. So we know that it's gonna be, so we can write it, we can divide both of these by 2. Let's just say 1/2 and 6/2. But this is just equal to 3. All right, but I'm going to write it as 3/1 because this makes it easier when putting it into brackets. Okay, all right. Since these are both positive, so we know that it's gonna we can just like write both as like, so it's gonna be something x plus something times something x plus something, right? Okay, so for the first bracket, we take the denominator, and then that's 2, so it's 2x, and then take the numerator, and that's 1. And then for the second bracket, we take the denominator again, and that's 1. So it's just x, and then take the numerator, and that's 3. So that's our final factorized form. Does that make sense? Yeah? Okay. Cool. So that's basically factorizing quadratics. Yeah. Okay, we're gonna move on to some well-known identities now. Let me just paste the list into here. These are used quite a lot in Olympiad algebra. Like I've personally used quite a lot of them while solving questions. So it's good to like memorize them, and I guess not memorize them, but like I guess be familiar with using them, because you're gonna, oh wait, I pasted it into that, because you're gonna be using these a lot. Here. Okay, we can do like, I'll just explain the first few. Well, you guys might have seen some of these because some of these are like very well known and like used a lot. So yeah. So the first one, it's basically just how we've been doing it. Like, so a plus b squared is just, you just expand the brackets. Well, this is basically just equal to a plus b times a plus b, right? A plus b. And then you just times each combination together. So a times a times b times a, and b times b. So we get a squared plus ab plus ab plus b squared. And then you collect like terms, and that's just 2ab, and that's just the right hand side, right? Well, the second identity is basically just the same thing, except it's not a plus, it's a minus. Okay, the third one, it's used quite a lot, and so you need to be quite familiar with this one. It's like difference of perfect squares. And then you basically just do the same thing as before. You just expand these, and then you realize that the middle terms cancel out. Wait, I might write this out. So you get a squared plus ab minus ab minus b squared, right? And then since these two cancel out, oh, well, this doesn't cancel out, but like these two cancel out, so it's just a squared minus b squared. Does that make sense? Yeah. Okay, you can also just prove these by like expanding the right side, but I'm gonna expand your knowledge a bit more. I'm gonna generalize some of these. Okay, I'm gonna generalize the top one, which is a cubed minus b cubed. I'm gonna generalize it into a to the power of n minus b to the power of n. Does anyone actually know what this is? Or do you guys have like any idea? Anyone? Okay, so I'm just gonna tell you. So actually, no. What if I tell you what a to the power of 4 minus b to the power of 4 is? Can someone like take a guess? I'll tell you what a to the power of 4 minus b to the power of 4 is, and then someone can take a guess what a to the power of n minus b to the power of n is. Okay? A to the power of 4 minus b to the power of 4 is a minus b times a to the power of 3 plus a squared b plus ab squared plus b cubed. Okay, look at this one, and then, wait, let me just change the color of my pen. Look at this one, and and this one, and then see if you can like spot any like similarities, and then try and generalize a formula for a to the power of n minus b to the power of n. Kingsley, would you like to give it a try?
And I make a wild guess.
Yeah, sure. Do you want to write it down?
Yeah. So maybe it'd be a minus b in brackets.
Yeah, because it's like it appeared in all of these, right?
A to the power of n.
Write it in powers of in, in
N minus 1, I think.
yeah.
Plus a
Mm.
n minus 2. This is a wild guess. Plus a b to the power of n minus 2 plus b n minus 1.
Ooh, that's not quite right, but you're very close. Um, you're very close. You're very close. Can I just say that? Well, it's um, well, you got the a minus b part correct. That is a part of every single a n minus b n. And you got the a to the power of n minus 1 bit correct, and then plus a n minus 2 times b. But there are a lot more middle terms. So there's actually a n minus 3b squared, and then a n minus 4b cubed, and then there's it's all the way up to like, oh, let me just make my pen. Can I make my pen? Well, it's dot 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 because we don't know what n is, so we don't know how many terms there are. But like it's all the way up to, let's just say, a cubed b n minus 4 plus a squared b n minus 3 plus a b n minus 2 plus b n minus 1. But you were very close. You just missed like all these middle terms. This is a bit confusing. What do you find confusing?
It's like just there's a lot of terms.
So like you're not confused about like what each of these terms represent, but you're just saying there's a lot of terms and that's like scary.
Yeah.
All right. Okay. For example, when n, let's just say, for example, when n equals to 5, it's going to be a to the power 4 plus a to the power 3b plus a squared b squared plus ab to the power of 3 and then b to the power of 4. That makes sense, right? Yeah. Okay. Does anyone want to attempt to prove this? Actually, should we prove this? I don't know if we have time. No, I don't think we should. Anyways. Okay. And then, so this works for all n. Let's say this works for all n. Works for all n. So if a n minus a to the power of n minus b to the power of n is like this, what's a to the power of n plus b to the power of n after looking at this one? Can anyone work it out? I'll give you a to the power of 5 plus b to the power of 5. Can I just give you a hint? A to the power of n plus b to the power of n does not work for all n. It only works with specific n. So I'm just going to give you what a to the power of 5 plus b to the power of 5 is, and then someone can have a go at trying to figure out what a to the power of n plus b to the power of n is. It's a plus b times minus a3b plus a squared b squared minus ab cubed plus. Okay, does anyone want to have a go at what a to the power of n plus b to the power of n is? Yeah, that was correct. But yeah, that was correct. It's just we have to note that it only works for n when n is odd. Do you know why? Would you like to explain? Would you like to give it like? Would anyone like to give like Would anyone like to try to explain why it only works when n is odd? Like, why wouldn't it work when n is even? Well, I'll give you the formula first. Well, it's a plus b, and then a to the power of n minus 1 minus a n minus 2b plus a n minus 3b squared. And then you go minus blah, 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 dot, dot, dot. And then you eventually get to minus a, b, n minus 2, and then plus b to the power of n minus 1. What would happen if n was even? Would anyone like to try and explain? Any ideas? No? Okay. Well, when n is even, there's gonna be an odd number of terms up to here, right? Up to here. That means this one is going to have to be a plus, because like each odd term is a plus and each even term is a minus. And then that means this one is a minus, and that just does not work with our formula. So it just doesn't work. And then we can try like a small even case, like a squared plus b squared. That just does not have like a formula that you can plug it into, right? So yeah. Does that make sense? Can I get like a thumbs up or thumbs down? Okay. One thumbs up. All right. Like, okay. So basically, all these formulas, you can basically just expand both sides. I guess expand the side with bracket and then you get the other side. Yeah. All right. So it's like actually really easy to prove. All right, let's move on to some problems. Do you guys all have the handout? Yes, no, maybe. Yes. Okay. Yes. Okay. All right. Let's do I think we only have time to do like a few questions. Let's put it here. All right. You guys can do question 1, 2, 3. I'll give you 2 minutes to do them. Should be enough. And don't write it down if you. Yeah, it was in the email. It's like at the end of the email, I think. Anyways, I've put the first 3 problems here.
Where do we do them?
Do you have some like pen and paper? Just write them down for now.
Wait, which 3 problems?
Here. Here. Can you see that?
The ones that are like drawn around these ones?
Which ones?
Is it these ones?
No, I don't know. These
Where?
ones. These ones.
Where? I'm just looking
You see the
at.
huge circles I'm drawing?
Where are the huge circles? Alright, these three. No, those no. Wait.
These
Where?
ones.
What?
Yeah.
Oh my god. Okay.
There. Hope you can
Wait,
see.
what does it mean by expand and simplify? Does it just mean expand to the other form or
Expand so that it's not in brackets, and then simplify
oh,
by collecting like terms.
can we just do it like somewhere random, like far away on the board? Because I don't have pen and paper.
Sure. Just don't do it too close to where the problems are. All right, we have 5 minutes left. I'll try and go through these. Can someone quickly explain question 1? It should be pretty simple. All right, you can unmute yourself.
Me?
Yep.
So question 1, it says expand and simplify x minus 3 squared. Wait, can I put x minus 3 squared? So then you can just square x, which is x squared, and then you like normally it would be like it would look like this, and then you did this, which is x squared, and then you do this, which is 3 minus 3x, and then this is minus 3x, and then that is 9 because two negative numbers make a positive number. So then it's x squared minus 3x plus 9, and then x, and then you can put these two together, so then it's x squared minus 6x plus 9.
Yeah. Okay. Question 2, someone else. Anyone else? No? All right. So we can basically, okay, what if I tell you that we use the first identity on the sheet? Yeah, you can just unmute yourself. Just go again. It's fine.
Wait, so basically for this you could just you could just first like make this like bigger, like into the other form,
Yeah.
because then that would look like a squared plus, wait, 2ab.
Wait, hold up, wait. I,
I
I think I
have
did something wrong. I think it's supposed to say a squared plus b squared is 7. Sorry.
Yeah, because a plus b, I looked at the problems
And
before
then,
class, and
and
then I looked at
then
it and I'm like, are we supposed to account for every possible value of a and b?
wait.
Because
Sorry.
A
Um,
plus B
that can
is 7,
go
and
into
A
b
plus B
squared,
squared
and
is
then
29.
that is 20. But then how do you find out these two?
sorry. It's supposed to be a squared plus b squared is 7, I think. Yeah.
Oh, so then that would just be 20. So since it's 2ab and ab is 10, that would be 10 plus 10 plus 7, which is 27.
Yeah. Yeah. Sorry. Wait. Yeah. Yeah. Sorry. And then third question.
Um, it's like a difference of perfect squares.
Yeah.
S- Um,
So
if you,
A is just
uh,
X and B is just 4, right?
yeah, so if you win just x minus 4, x plus 4.
Yep.
Is that right?
Yep.
Isn't it because like because like the last two things cancel out? So if there's like something like x something minus a number with no x, it's always like this, like that kind of format.
Mm-hmm. Yep. All right. Okay. I think just do the rest of the problems if you can as homework. They should be pretty straightforward, and if you can't like solve them, basically I think just refer to the identity sheet and you can scan and send like your answers to me or something. My email address, I'll type it out. Oh my god. 51, wait, can you see? 51046. Yeah, there, that's really small. There. You guys can email me. Yeah. I think this lecture was relatively simple, but next time we're gonna go through like polynomials and like um factorizing, like dividing polynomials by polynomials and stuff. And then also like rational root theorem and stuff. So like yeah, it's gonna it's gonna get harder. Yeah. Any questions? No? Can they go now? Okay.
Yeah, can we go now?
Yeah, you guys can go.
Thank you. Bye.